So thank you, Curtis, for the introduction. It's a big honor for me being here, one of the representatives of Vienna IXP, and I think LINX is doing here a good job in bringing together the community and do these events 4 times a year. I think this is a point where we have to improve and get better and can learn from a big exchange point like LINX. So who is we and who am I? My name is Harald Michl. And as you might guess from my email address, I'm employee of Vienna University. So Vienna University, and to be precise, Vienna University Computer Center, in a department where we provide external services, which means we provide the academic network for Austria, for the educational sector, with one hat wearing, and the second hat is we are also operating the Vienna Internet Exchange. This is the reason why I'm here and why I'm talking to you. I thought a good presentation needs a good introduction, so I thought, okay, let's make a little bit of a comparison, because if I start to explain what an exchange point is, this would be, I think, the wrong start here, because all of you know that, of course. And so I thought, okay, what are numbers that might be interesting, and just to give you a feeling what VIX is compared to LINX. So I thought, okay, when was the service started? So I thought, okay, LINX started in 1994. Vienna Internet Exchange started service in 1996, so this is 22 to 24 years. In this case, LINX is better by the factor of 1.1. So, okay, a little bit better. Then next number, what you could see is, and I hope these numbers for LINX are correct, because I collected them about 2 weeks ago, and as we heard, there are coming new members nearly every week. So in my case, it was 853 for LINX, connected ASs, and 145 for VIX. That's again a better factor for LINX by 5.9. Okay, next key performance indicator could be the peak traffic, and as you can see, of course, LINX is much bigger than VIX. We have around 611 gigabit traffic per day peak rate, and this was the Microsoft update last week, and LINX is far beyond 4 terabit. Then we have another number we can talk about. Factor is 7.1, so it's a big factor. Another factor could be number of POPs. I mean, we are operator, we are very neutral operator, as we are a university. We are only present in the university itself and at carrier-neutral data centers. There are only 2 carrier-neutral data centers in Vienna. Additionally, the Vienna University makes 3, and if the number is correct, there are 16 of LINX. Only in London. I didn't count the other POPs LINX is operating. So this is also a factor of 5.3. And you know, if you do some statistics, you want to win at least one time. And that was the reason where I thought, okay, what is interesting about IXPs? And as we have heard at the survey, it is stability. So stability is very important for members of exchange points. And so I thought, okay, what is an indicator for stability? And I thought, okay, the existence of the legal entity. How long does the legal entity exist that runs the exchange point? And if you look, I mean, LINX is run by LINX Limited, if I'm correct, and LINX Limited was founded in December 1995, which means it's not... No, the limited? Okay, that's around 23 years now. And, well, as you can see, VIX is run by Vienna University. Vienna University was founded in 1365. So we have a long tradition of exchanging data and information, and recently also use IP for that. But if you look at this, we have now a factor of 28.4 of having established a legal entity longer than LINX. So this is also something I can be proud of. The main topic of the presentation is about route servers, and we heard already about the functionality of route servers during the presentation of Juniper. And I wanted to talk about what we have thought about route servers when we implemented them, and how we operate them, and how they are configured. I mean, I guess all of you know what route servers are good for. You have, instead of the need of an BGP session between all of the ASs on the exchange point, you can have with nearly the same functionality BGP sessions between the ASs and the route server. A route is then forwarded, or the information is sent to the route server distributes the information to the other ASs. And the normal way, and if I understand it correctly from the LINX documentation pages, so this is also the way LINX route servers behave, is that you use BGP communities to control where your prefixes are forwarded to. So I prepared an example, which means if AS1 has a prefix, it is distributed to the route server. If there is no community, the prefix would be forwarded to all of the connected ASs by default, and there's a possibility of adding communities to influence the behavior of the distribution of the route. So in this case, 0.2 would mean that the route should be forwarded to all peers except AS2. So which would result in the prefix information forwarded, in our case, to AS3 and AS4. Which also means that you would have to have a kind of master routing table here where all of the prefixes of all of the peers are collected and then forwarded according to the community set or not set to all of the other peers. Which also means that if you have one prefix coming in from here to here, and you imagine you have, let's say, 100 peers connected here, you have 99 decisions to make whether to forward the prefix or not. This is an important information we see later on. Imagine we have also a connection here. And the AS3 now also announces the same prefix to the route server because it has connectivity to the same prefix, of course with a different IS path. So we could expect that for AS2, the best path, if there is no prefix coming from here, would be the way from here. But if you have standard BGP behavior, BGP only forwards best path information. Best path is this one here, as this one is declared not to be forwarded here. Normally, if you don't have any special workarounds, the prefix would not be forwarded. So this is a disadvantage we thought if you have a route server, global routing table, and act depending on communities. Another thing we thought is that, okay, BGP communities only can control where prefixes will be sent to, but you have no possibility to influence which BGP prefixes you want to receive. So that means if AS2, in this example, forwards prefix information to the route server without any communities sticked on it, the route server would forward this information to all of the 3 ASs in our example because there are no communities on that prevents it to be forwarded to AS1. We can just assume if AS1 doesn't want its prefixes to be forwarded to AS2, it also wouldn't want to receive prefixes from AS2, but it cannot influence this behavior by sending communities because it cannot influence the prefixes it gets from the route server. It could filter at this point, of course, but this would be maybe negative behavior because if I filter away this path and there would be a second best path, I wouldn't receive that. So these thoughts then were the basic information for us how we thought that we want to design our route server. The design itself is from 2010. I mentioned this especially because, especially with regard to BGP communities, there have been changes since then. In 2010, there was first of all the problem with these 32-bit AS numbers. They were quite new, and signaling with BGP communities with only normal 32-bit BGP communities, it's hard to send commands for 32-bit AS numbers. So we thought there have been some workarounds with private AS numbers mapped to 32-bit AS numbers. We didn't like that, and so we said, okay, if we find a way to get rid of the BGP communities at all, we solve the problem with the 32-bit AS numbers as well as the problem that the prefix distribution is only one way definable. The next thing is we said, okay, we want to have route servers because they have obviously some advantages, but we want them to behave, or the peering with the route servers should behave as similar as bilateral peerings would be. So there should be only a route exchange if both parties agree, which is the same like, I mean, a bilateral peering only comes up if both sides configure the bilateral peering. If one of them decides to remove it, it will go down, of course, or never get up. And also we want to have the best path calculation behavior of the route server as similar as possible, like bilateral peerings. And then, of course, from the user perspective, the more simple it is, the better it is. So make it simple for our customers or connected networks. So let all of the connected participants define their defaults. So may they default may they peer per default or not, or may they want to have some filters or not. And then, if you have defined the default, you configure only your exceptions, and you're done. And as it was 2010, IPv6 was not so established yet, but we said, okay, if we build something, we want to have the same feature set for IPv4 and IPv6. So that was where we started on. Now, how does it look like? I mean, the difference between the example I showed you before with the community-based attempt and what we build is that we don't have this route server global routing table. Our route server has only local routing tables where the BGP prefixes from each RS are collected. And then, instead of exporting it to one route server global routing table and then redistributing, we establish pipes. So we use the BGP software BERT for enabling the route server service, and only for those ASs that accept the peering request from the opposite, we create pipes between those routing tables. And for example, here between AS1 and AS2, as AS1 refused to have a peering with AS2, there is no pipe established, which also means that we collect prefixes here and distribute them along the pipes only if both sides agree to have a peering session established. This has the big advantage that we have to filter the prefixes only once, and then there's no further filtering, because if there is a pipe, the prefix information gets forwarded, and also the best path calculation works from our point of view better, because only prefixes end up in the routing table that should end up here. And to compare it with the example we had before, if we imagine a connection here, and we have the announcement we had before, then the route will be announced first to the route server, but also to the AS3. AS3 announces the prefix also to the route server, and then you see, according to the pipes, what happens. So for AS2, they will only get this routing information here through the pipe from AS3 to AS2, and AS2 will learn this prefix here, but with the AS path of AS3 and 1. So that means that in the former example, second best path is the best path within this routing table, and AS2 will get a path to the destination via this way here. The big advantage here is that here is no relation, and we don't have a problem that we have to filter out anything. Filtering is done already here, and the number of pipes is representing the number of acknowledged peerings. So in the former example, we had always n-1 filtering decisions to forward a prefix or not. In this case, it's only the number of pipes where the prefix has to be forwarded. Is a pipe here, then it has to be forwarded. Is there no pipe, no prefix will be forwarded. So this is really simple. The filtering process is much easier, and we don't have the need for a route server global routing table, which also means it's better in terms of memory usage and performance. And to give you a feeling how it works, how it's controlled, as it doesn't rely on BGP communities, which means it doesn't rely on the BGP config of the peering routers themselves, we have to find a different way. So we choose to integrate the functionality in our web interface, in our portal. So if you log in and you choose the ISP or S number you're responsible for, you can first of all set your own MD5 password for the route server peering. And then you have to just configure the same MD5 password on the routing session. Then you can set the defaults, so either peer or not peer with per default, which also means if you click on here on peer and a new member joins the route server, you peer automatically with that peer. The other way would be to set the default to do not peer. Then you have to explicitly set to yes where you want to peer. Next thing is we provide prefix filtering, so you can say, please just send me prefixes from my peering partners where they pass the routed prefix filter that we get from from all of the peering partners. Or you can say, no, please just send me all the prefixes they send and I will do filtering on my own. And the next one, sort order, is just the sort order of this table here. Then we have, as I mentioned, 3 POPs. And you can say, okay, if the routing information is completely identical on more than 1 POP, and I have 1 POP of presence, and 1 preferred POP of presence, I can define it. In the example of Arconet, the preferred site is Vienna University. Why is this the case? Because it's our own POP and we own everything there and we have the best capacity there. So if we have several chances of getting the same routing quality of a prefix, we chose our own POP. Further down, you see, and this is just an example, you see here the other peering partners. You see on the right side, is there traffic or not? It's too small to see how much traffic it is. You can then click on it and see a detailed graph, but at least you see, is there traffic or not? And you can see what I have set. So in this case, peer like default, and you can see what the other side has set. So in this case, it declared yes, it's green, so there's a peering established. We also see who is the peering partner, how many prefixes are there according to the prefix filter. We can click on it to see it, and we also see the NOC addresses in case we want to contact them. That might be useful if we want to contact the other side. Then we have a second one that is established. And here, for example, some peering that is not established. Why? We have peer like default, but the other side is not participating. So this is a reason why there's no peering. If you see a little bit of peering traffic, that would mean that there has to be a bilateral peering. So, of course, even though there is no established peering via the route server, it might happen that there is traffic, and then it is because there's a dedicated bilateral peering session configured. Another example is, in this case, we said, okay, peer like default, which would be yes. You see here traffic, but the other side said no, for whatever reason. Sometimes it's because they want to have the ability to announce certain prefixes only on certain peerings. Then the other side set the route server ping to no, and we see this because the background here is orange in this case. This is an example of a case where we said explicitly do not peer. So this is an exception from our point of view. The other side said yes, but as this one is also a customer of Arconet and we do not peer with our customers on the exchange point, we explicitly set it here to no. So there's no peering and no traffic on the, you can see that also means there's no bilateral session on the exchange point because there is no traffic. Here's also another example. We set here explicitly to peer. The other side enabled it as well. But here we have an exception because of the filters. As Microsoft doesn't document prefixes in the RIPE database, we are interested in also getting prefixes that are not there, of course. And another feature I didn't mention so far is it's also possible to set AS prepends per peering partner. So if we have a routing partner where we said, okay, in this case we want to have a prepend of, for example, 2, we could set this here to from 0 or nothing to 2, which makes the route worse compared to other ways that might exist. So, as I've written, the system was implemented in around 2010-ish, and so far we think it works quite well. There's not so much negative feedback. I'll come on to that later. One of the biggest advantages is that if you have established it once, you don't have to configure anything on your router. You just have to configure it on the route server portal. Of course, it is necessary that you trust us as an exchange point operator, that we do the correct filtering and have the correct pipes. But I think this level of trust has to be there anyway, independent of how the route server works. If the route server is broken or the functionality doesn't work, you end up in a mess anyway. And also to mention the disadvantages we currently see. So you have to log into the web interface at the moment. It would be an improvement, I think, if we offer some kind of API where you are able to automatically configure or read the current state of the configured peerings. And of course, I'm not sure how many other exchange points offer the service in this way. So this is just another way of how you configure your route server peerings. And as this is not so similar as it is common, it might be a disadvantage in itself. So this is how it works. And if you have any feedback about this idea, I would be more than happy to get information from you. If you like it, if you dislike it, if you think that should be done, if you think that should be improved, that would be really important information for me. Okay, so as the introduction showed the differences between LINX and VIX, I thought I might conclude with what I think we have in common, which is that we have a long tradition for working for the good of the internet, or trying to improve technique, trying to bring people together and just make things better. And I hope you agree that LINX and VIX are doing here a good job. One thing I want to mention is that there will be an event next year, and I'm more than happy to say that this will not be organized by VIX, NIXIZ and VIX.hu, but that also LINX is going to participate and be active part of this event we have next year in Zagreb. So feel free to come. If you need any information about this, please contact me. So that was it. Any questions, or did Malcolm run out of my time?
Any questions for Harald while he's here? Because he has come a long way, so I think we should allow him some question, at least, if someone has one. Oh, we got one question. Up.
Hi, Rob Golding, Astutium. You gave some interesting numbers at the start. How many of the local ASs are present on VIX, which is presumably a better number to know? What's the penetration into Vienna's ASs?
So you mean with local AS, you mean ASs that are kind of at home in Austria?
Yeah.
Well, we have, I think, around 50-50, but I think the question is more interesting the other way around. Are there any significant ASs that are not present at VIX, correct? Because if you connect there, the most probably you're interested in getting a very good coverage of the Austrian sector. Mm-hmm. And I would say that most of the, let's say, 80% of the interesting Austrian ISPs are connected directly, right, and the other might be only one AS away from that. So I think the coverage within the region is quite well. Also, not only the Austrian area, but going to southeast. So from the Balkan region, we have a lot of incumbents from the southeast European region connected. So it's not only the Austrian community itself; it's the region, the Central and Eastern European region that connects to VIX. I mean, all of the member list and so on is public. I just didn't want to misuse the presentation here to do a lot of advertising.
Okay, and one second thing. With the reliance on AS to AS matching for bilateral peering, are you under pressure to also apply levels of censorship because you have that control over the route?
With censorship, you mean that we filter information? Yeah. Then there's the question, filter on BGP level or filter on packet level?
Well, do filtering of content at the exchange.
Yeah, so we always try to claim and to do that we only provide layer 2 connectivity and don't care about what you're transferring. So we are not interested in what you are transferring, and we don't want to see it, we don't want to know, we just want to provide a reliable platform where you can do whatever you like.
Any other ones? Okay. Thank you, Harald.